Hi, in this video we're going to talk about how to use the sphere range distance and make the previous example the better result. So let's first open our example file, sample 18, the sphere detection version 2. And you can see that this is a file which is the result from the previous video, and we already created its free logic for this thing. And the first one is the default and the move forward as speed free, and the rest of them is the symmetrical, two of them. Someone in my left, 0 to 100, and turn to the right, and someone on my right, minus 100 to 0, and rotate to left with the speed 150. So we're going to use the sphere range distance to make this more accurate result. So let's first introduce what is the sphere range distance. Let's first place our agents. You can see that this is our agent, and from the center to the edge of the sphere there's a distance. The distance is the length between the center of agent to the edge of the sphere range. But please notice that this distance is kind of the relative one. So if someone is in the center of here, the distance is 0, and in the edge the distance is 100. It's always 0 to 100, and this is the relatives, the distance. So if you increase the size and the agent size here, or you just increase the sphere range, the distance is always 0 to 100. So once you've done the logic setup, you can skip the setup when you change the radius or something. Everything will keep the same, just to use the relative distance. Let's deplace and place it again. So let's create a logic. If someone is near me and for example is too near here, for example 0 to 100, here is the 17 and 50, so we needed to build a logic here. Sphere range, someone in my sphere with distance less than, for example 60, and with some of the default logical value, the blur is 60, for example the 15. So you can see that from the 45 to the 75 there's the blurred the range. Inside of this range it will activate this logic, and let's just Control C and paste here 15. At this time you can see that the avoidance can be more smooth. Let's play back. Please notice this guy. Okay, let's reset. This will be smooth than previously. So let's just compare that. If we just disable this sentence, you can see that the avoidance is very big, just like this, and here, wow. So we just resume them back to make the avoidance smooth. And also we want our agent speed down if the other agent in front of them. Let's create another logic here, in front, slow down. Okay, and this is pretty simple. We can fill the sphere range from minus 10 to 10, and with some of the fuzzy range 10. Okay, so that is the between the 20 to the 20 minus 20 to the positive 20. Our agent will try to slow down the move forward as speed. You can see that this is on the forward as speed is free. The slow down, we can specify the speed as 0.5. Okay, and let's just play back our simulation. You can see that the agent will slow down if there is others in front of them. Let's see that again. it will try to avoid each other more accurate. And also we can increase this value a little bit to make them feel each other when the distance is 90, to make that more smooth. Okay, here they can avoid each other with the smooth and slow down result. Let's just add some of the rotation value in the default, make them rotate back if they far away from the center of origin. On the move and rotate it to the left at speed 45. We need to remove this sign 45. Let's play back our simulation. You can see that if the agent is nothing in front of them, it will try to move back with the rotated 45 degree per second to the left. And let's just continue adjust some of the parameters for making the simulation better. You can see that there are some of the jump result, jitter result, and the sum of agent is also collide each other. So let's just continue tweak the parameter inside of each one of a logic node. Let's first decrease the jumpy and the jitter result. We need to make it fuzzy out. For example, 10. 20 about. At this time, they will not jump. Everything is the more smooth. And also we need to add the in front detect and make the agent can detect some agent in front with a distance to make everything more smooth. 80. So from the 100 to 60, it will detect someone and try to slow down. We change that to 0. We change the speed to 0. Please notice that there should be a blank. And let's play back our simulation. You can see that the result is better now. And also let's just tweak the parameter here, because the 100 I think is too big. The agent can detect someone behind them, which can decrease this value. 85. The minus 85. Let's run the simulation again. Okay, at this time you can see that the collision result is much better, and almost no agent collide each other too much, and this result is much better than the previous video we achieved. There are some of agent collide each other, and also in the later in the render session you can remove some of the agent. It's not very easy to avoid collide. So this is an introduction for the sphere range with the distance. Thank you for watching. See you next time.